Welcome back. Today we're going to talk about polar coordinates. And the thing we need to know about polar coordinates is that we're dealing in a different kind of a plane. We're dealing with a circular plane, and what it's going to do is it's going to give us the coordinates as an angle and a radius. Okay, so it's going to kind of bring together some things that we've been talking about with like vectors, and it's going to bring some things like the unit circle kind of together, where we're talking about angles and radius, and we're going to kind of do a fusion here. So let's look at what that looks like. All right, so what I've got here is a polar coordinate plane, and what you can see is, like the unit circle around, I've got my angles, and then as I look at the other coordinate, so that's going to be um, actually a circular coordinate, and my other axes are just numbers. And so with polar coordinates, our points on them are going to be based on radius. So how it's called a directed line. How far does it reach out? So r. So it could be 1 or square root of 2, whatever. It's the magnitude of a vector. Remember that, the length of this line, and then it's going to open up. So that's how far it goes. It could go in any direction, how far it goes. And then how much it opens up is theta. And so as we start to work with polar coordinates, understand we're not going left and up, we're going out and to a certain angle. So our line is going to be a certain length, whether it's this long or this long, and to a certain angle. So let's look at what that means. Let's talk about polar coordinates in general. So to work with polar coordinates, we're going to have, as you can see, it sort of looks like this, and I'm only drawing it as an angle because it's going to help us relatively put them where they go. This is the polar axis. Okay, so this is, this part here, our polar axis. That's where theta equals 0. And the concept is we're opening up to a certain angle, theta. And the length of our line, this should actually be a point at the end. The length of our line is r. Okay, so that's the radius. That's the x squared plus the y squared, which we're going to talk about in a minute. And our point has the coordinates r comma theta. So theta is not just, hey, find the angle between these two vectors. Now it's actually a coordinate saying, hey, on my polar coordinate, it's how much. Okay, r is a directed distance. It's a directed distance. So how far does it go? 3, 4, square root of 2, whatever it happens to be. So when we look at this example and we're plotting points in the polar coordinates, so we're going to plot these points with a given coordinate. So what does it mean? Well, this means that if I have 2 pi over 3, this is my r, and my pi over 3 is my theta. So to plot this, here's what I'm going to have. This is going to be my axis down here. My angle is going to open up, excuse me, pi over 3. Okay, my angle is going to open up pi over 3. And because r tells me my directed line, this is 2, so my coordinate is going to be 2 comma pi over 3 because it opens up pi over 3 and 2 is the length. Okay, so let's check this out. -1, 3 pi over 4. Now what you're thinking, you might be thinking, maybe you're thinking, I don't know, is like, well, how's r negative? What does that mean? Like typically you always said, r was positive. So what does this look like? Let's just think for a second here. If I have, a directed line segment and it opens up 3 pi over 4. Well, now think about this for a second. The way that I drew this doesn't really make a whole lot of sense. Let's make it a little bit more to scale. 3 pi over 4. So like pi is 180, and so 3 pi over 4 would be, more out this way. Let me get my pen tool here. Oops, hold on, hold the phone. There we go. And so 3 pi over 4 is going to be more out this way. And actually, I should make this a point. Okay, so this opens up 3 pi over 4. If this was 1, my coordinates would be 1, directed line segment, opened up 3 pi over 4. Well, when I talk about -1, it's the opposite. And so really, I have this directed line segment that's opened up, and really my point is down here because it's the opposite of. So 3 pi over 4, the opposite of. So not this point, but this point is q, -1, 3 pi over 4, because it's opened up 3 pi over 4, and then it's the opposite. Okay, so think about that for a second. All right, r, negative 45, so I can conceptualize where that's going to be. There's my polar axis. And if this opens up negative 45, the question is, okay, this 3. Here it was straight up. It opened up to the angle and it was 3. In the second one, it was 3 pi over 4, but because it was negative, it was reflected. Well, if this is a negative angle, does it mean it has to be reflected? No, because it's a directed line segment, meaning if it's negative 45 and it's positive, it's in that direction. And so 3 comma negative 45 is down here because it's not, for Q, it was going 3 pi over 4, the opposite of 1. In this case, it's going negative 45, but it's in that direction of 3. Okay, so I hope that makes sense. So negative means you go in the opposite direction of where the pointing, and if you have a positive, it means it goes in the same direction. So if the point has the polar coordinates 3 pi over 3, think about this for a second. If I've got 3 comma pi over 3, it opens up this way, pi over 3. Okay, so what else could happen? Well, as we know, since it's a pole, it goes around and around and around. One of the things that we need to understand is, like, there's more than one. In fact, there's infinite. And so one of my possibilities is that it goes all the way around again. Okay, so this angle would then be pi over 3 plus 2 pi, right? Well, in reality, it could go around 2 pi, and then it could go around again, so plus 4 pi. And you see how this pattern would go. We'd keep going around in increments of 2 pi. So one of my possibilities is going to be 3 comma pi over 3 plus 2 pi n, okay? Because n is some number where it's like, hey, it goes around again, it goes around again, it goes around again, it goes around again, okay? My second possibility, and you're going to have to stick with me here for just a second, is I've got this right here, right? And if I could figure out the opposite angle, right? So the opposite angle, because check it out. So really, to get to 3 pi over 3, if I opened up this much, right, and then it was the opposite, so like over here, so if they form a straight line like this, it's 180, right? So this angle here would be pi over 3 plus pi. So that's going to be pi over 3 plus 3 pi over 3, so it's going to be 4 pi over 3. But to get to, because this is the point that I want, right? To get to this point, it would be negative 3 comma 4 pi over 3, meaning I didn't just open up my angle and get to 3 up here. What I did was I went farther around, can't even make my arm bend that way, and then reflected it back across. And so another way to find an angle is to say I take my angle plus pi. So I'd say my angle, so pi over 3 plus pi, okay? And then all multiples of 2 pi after that, right? And so, but then my r would have to be the opposite of, because I went farther than I needed to and reflected it back. And so what's the synopsis of this? Well, I could say, if this is the generalized form for going straight there, to go past it and then come back is going to look like this. Negative 3, comma, theta, plus 2 n plus 1 pi. Okay, because if I factored all this out, I've got my theta, so pi over 3, and then if I've got 2 pi plus pi, that would, if I factored out a pi, that would be 2 times n plus 1, so this is my pi times 2n plus 1, meaning I went pi around, and then other multiples of pi 2 pi would get me there. And so this would be negative 3, comma, pi over 3 plus 2n plus 1 pi. Okay? And so in general, let me sum it up. In general, finding all coordinates. Okay? Looks like this. You got two possibilities. R, comma, theta plus 2 pi n. That's the one that's more conceptually easy to understand. I go there, and then I could go around, back around again. Or I could go the opposite of R. So I'm going to go around halfway and then come back. Comma, theta plus 2n plus 1 times pi. Okay? And that's going to be where n is any integer. So for these, you're going to need to have two answers. So you're going to have the one where you go straight there and do 2 pi. Then you're going to have one where you've got, you know, plus the pi, the angle plus the pi, and then come back. All right, so see if you could try this one. I'm going to go through, but you can pause and see if you can get it as you solve for both of them, both the r and the negative r. All right, so I'm going to roll straight through. If you want to pause it and try it, you can. So I've got two possibilities. One is 2 comma pi over 6 plus 2 pi n. Okay, and the other one's going to be negative 2 comma pi over 6 plus 2n plus 1 times pi. That's all there is to it. Okay, so I got to take into account both of those pieces, and that's going to give me that.